Alright, so welcome to our new topic now in probability, which is the Bernoulli trials, or otherwise it's sometimes called the binomial distribution. So I have that written there at the bottom. Yeah, it's two different words for the same thing. So first I'll just give a brief explanation as how the Bernoulli trials are really useful. They can kind of help us do calculations that otherwise would just take absolutely forever. So the example I chose is, imagine you're flipping a biased coin. There's a 60% chance of you getting a heads and 40% chance of a tails. So biased coin just means it's not 50-50. So 60-40. You're flipping it 10 times and you're trying to find out the probability of getting exactly 6 heads and 4 tails. So what's the probability? So there's two ways you can do it. You can either go, let's say one is doing it manually, or two using Bernoulli. So if you were to do it manually, you would have to find out the probability of getting heads, 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 that's 6 heads, then tails, then tails, then tails, okay? Or, which in probability is plus, remember? The probability of getting heads, 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 tails, heads, tails, 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 and so on, okay? Or, so there's loads of different combinations, the different orders you can get the heads and the tails in. And you need to find out the probability of each individual one and then add all of them together, and all together in total there's about 210 different ways you can do it. So 210 ways, you have to calculate 210 things and then add them all together, which is a lot. So it's just that's a massive trek. However, with Bernoulli's trials, so Bernoulli, all you need is one formula and a calculator. You could do it by hand, but calculator makes it a lot easier. Yeah, so it's just much easier. So those are the kind of questions that they're useful for. So I'll just go down here and I'll show you what the Bernoulli formula is, okay? I may as well just make loads of space. So here's the formula and the explanation. So just look at the formula first in the top left corner. So it's n choose or. That's what this kind of bracket thing is called. This is n choose or. So it's not a fraction, even though it does look a little bit like it. We'll explain that in more detail in the next video, so just kind of accept that for now. P to the power of or, so it's n choose or times p to the power of or times q to the power of n minus or. So all of these are multiplied by each other. So in this case, n, the thing n you see there twice, is the number of trials in the experiment. So it's how many times we're doing the experiment. So say for our coin toss example, this one we were talking about earlier, n is equal to 10 because we're flipping the coin 10 times. It should be, that's its n, but it should be 10 times there. Yeah. Or is the number of successes, so the number of times we get the outcome that we want. So sometimes we call this either a success or a failure. So where p is a success and q is a failure. Sometimes it's not so easy to tell what's a success and a failure. So if you flip a coin and you get a heads or a tails, neither of them really are a success or a failure. But what you have to do is you have to choose one of them to be called a success and one of them to be called a failure. Okay, it's just kind of the names you put them. You could call it like yes and no, or red and blue, or whatever. But we're just going to call it success and failure for the moment. So number of successes, the number of times we get the outcome that we want. So or is equal to 6 in this case. So we're calling heads a success, and we want 6 heads. So that means we want 6 successes. P then is the probability of successes, so the probability of the outcome that we want, and in this case that's 0.6 because the probability of a heads is 60% or 0.6. Q then is the probability of failure, or the probability of whatever the other outcome is. So in this case it's the probability of a tails, so it's equal to 0.4 because 0.4 is the probability of a tails. So that's what each of the different numbers or letters stand for in the formula. And one thing I'll just mention here quickly is that P plus Q is always equal to 1. So if they don't give you both of them, if they only give you P or only give you Q, you can figure out the other one just by using this formula here. So P plus Q is always equal to 1. So there's one more thing you need to know about Bernoulli's trials, and those are the 4 conditions for Bernoulli's trials. So it's sort of the definition, and you need to be able to list all 4 of them in an exam, because sometimes they'll ask you to write them out just the words without using the maths at all. So it's a little bit annoying, but it's just one little definition you need to learn off, and then in the next video we will demonstrate using Bernoulli's trial. So I know it's sort of hard to understand it just when I'm kind of writing all these definitions and the formula, but it'll help in the next video when we actually do a question on it. But first I'll just scroll down here and we'll write the conditions for Bernoulli's trials. So here I've written them out here just quickly, the 4 requirements for Bernoulli. So unless all of these requirements are met, then you aren't able to use the Bernoulli formula to answer a question. So all of these have to be true before you answer a question on it. So there has to be a finite number of trials, and what this means is there has to be a certain number. It can't go on forever. So normally that'll be pretty clear from the question. There can only be 2 possible outcomes. So we call these either success or failure. I spelled success there, should be another S. Success or failure. So for example, if that was kicking penalties in a football match, success would be scoring a goal and failure would be not scoring a goal. So you have to simplify it to just 2 options. And whatever the trial is, there can only be 2 options. If there's more than 2 options, then Bernoulli's trial doesn't work, basically. The trials all have to be independent of each other, and the probability of success has to be the same for each trial. So those are sort of similar, so that's why I kind of drew this little bracket around them. So an example is, I think they asked in one Leaving Cert question was, there was a girl shooting free throws at a basketball match, and they said that there's a certain probability that she'll score the free throw, but if she misses the free throw beforehand, then there's a lower probability that she'll score because, I don't know, she kind of demotivated, she missed the last one. In that case, you can't use Bernoulli's trials, okay? Because the probability of success changes depending on what her last shot, if the last shot went in or not. So that's really, really important that you have to know that the trials have to be independent and the probability of success has to be the same for each trial. So again, this you need to learn off the 4 requirements for Bernoulli's trial, and then you need to understand it so you can tell if a question, if you're allowed to use Bernoulli or not. The formula is in the tables book, but you do need to understand what each of these mean. And then in the next video, we will look at doing a question like this coin toss and how to use Bernoulli's trial for probability questions. So that's all there is for this video. We'll see you in the next one where we're going to do a nice long video with loads of different questions, how to use Bernoulli's equation. Don't forget to like and subscribe, share them with friends. I will see you next time.